My name is Raphael Ho. I'm a student at University of Toronto, and this is my research on the proximity and feeding rates of mallard ducks. We're first going to go through the introduction, then the methods and materials, results, discussion, and finally the conclusion to this research. So what is the purpose of this research? We're going to explore the paired mallard feeding behavior and rates during the autumn season. Why I chose this is because there's not a lot of other studies that focus on the feeding rates for paired mallards during autumn, and also because I have a particular interest in bird ecology and biology. Furthermore, how does a mallard look like? This is a male mallard. You can notice it by the green feathers on his head and neck, and also the curly tail feather. This over here is a female mallard, and you can notice it by the brown speckled plumage, and also the blue striped wing. Like there's a stripe where the wing is. The mallard duck is seasonally monogamous, and what that means is that they have a new mate every single year. We're particularly focused on the feeding rates between these mates. So this is a video of the mallard duck, and mallards are actually a dabbling duck. And what that means is that they feed in 3 different ways. They dip by grazing on the surface of the water. They dunk by putting their head and neck into the water. And finally, they tip up by putting half of their body into the water and their tails into the air. So this video will show you the tip up technique. This is to reach food that is closer towards the bottom of the body of water. Over here is also a male mallard doing the same technique. Furthermore, the sex ratio is skewed towards male mallards, but this is marginal as only at 60%. However, this can cause competition for male mallards, and fully knowing that mallards are seasonally monogamous, the male paired mallard tend to have an aggressive behavior towards other male mallards that usually are unpaired, and we usually call this mate guarding. Their aggressive behavior can be anything from chasing away, from quacking loudly, to flapping the wings very loud or very fast. So the pair bonds. So mallards finish pairing up by November. We can see this we can also see they're pairing up by their courting behavior. And finally, we can also see how close the mates are. And when they're relatively close to one another most of the time, it shows that usually they are paired up. Here is a video of courting behavior of mallards. I can see their heads are bobbing, and I actually saw some of those mallards performing this behavior at the pond of my study. So furthermore, upon researching for a hypothesis, I came across Ashcroft's study on the common eider. And in his study, he showed that when a male common eider is closer to a mate, they have a lesser mean feeding rate than male common eiders that are farther away from their mate. And a common eider is also a bird that has seasonal monogamy. So I asked this question, is this the same for mallards? And that goes into my hypothesis that male mallards will have a lower feeding rate when they remain closer in proximity to their female mate. And my prediction of why this is because males will perform mate guarding techniques, which will cause them to have a lower feeding rate. Furthermore, my statistical hypothesis have a null and alternative hypothesis. My null hypothesis is there is no statistical significance of feeding rate in the proximity of the male mallard to the pair formation. My alternative hypothesis is average feeding rates of male mallards in close proximity to the pair formation is lesser than feeding rates of male mallards in far proximity to the pair formation. We're going to move on to our methods and materials. So the study area is Jeffreys Pond, Markham, Ontario. This is a panoramic shot of Jeffreys Pond in September. In hindsight, I should have shown this pond with some mallards in it, but you have to trust me that there are mallards living in this pond. If you want to replicate the study, you can do so pretty easily because there are 9.5 million mallards in North America, and they're one of the most abundant ducks in North America. Furthermore, this is a bird's eye view of Jeffreys Pond, and I actually highlighted this pond in green and yellow. So in the green areas, that's where the duck would dunk and tip more often, and in yellow is when the ducks will dip. And the reason why is because of probably the shallow and depthness of the pond. As deep areas, the duck they have to dunk or tip up to reach the food on the bottom. Furthermore, we're recording our observations through items per minute the same way that Ashcroft did. And we're recording this only in the green areas, as dunking and tip up is more noticeable to record than dipping, as it's very easy to tell when they reach for their items. So we're going to measure at the same time both male and female in their pairs. So the observed pair must be isolated as much as possible. This is to reduce any other variable of having a large group in an area. But if there's another mallard that do come within the pair, we're also going to observe if there's any mate guarding behavior regarding the aggression of the paired male mallard. We're also going to measure this in the pair proximity. So we're going to measure the closeness. Close as in the male is within 3 meters radius of the female, and far is vice versa. The male is farther away in 3 meter radius of the female. And furthermore, what makes a pair? If they show synchrony, if they avoid other mallards, and finally, if they show courting behavior. Our approach, to sum up, we're going to label the mallard pair as either close or far. We're going to record items per minute via tip up or dunking in those green areas. And finally, we're also going to record if there was any aggressive behavior the male mallard ducks made. Any materials that we need. We need binoculars because it's hard to see the green areas in the pond. We need a stopwatch. You can use your phone. A clicker. I use this application that you can download on your phone. And this clicker is convenient as it has 2 clicker options. And finally, some sort of recording device to write down the number that you got from your clicker. Our analysis, we're doing a 2-sample student t-test. This is one-tailed because I have an expectation that the close male mallard will have a lesser mean. And finding a level of significance, as you know, it's average of if it's lesser than 0.05, we're going to reject the null hypothesis. Let's move on to our results. So figure 1. So figure 1, it shows the t-test between the close, so the male and female of the close, and it shows a p-value of under 0.05, which shows there is a there's significance in their average means. We also show the t-test between the far, and this because it's lower than 0.05, there is significance in the male and female of the far mallards. Thus, male mallards for both far and close feed less than female mallards. So this is as expected. They just feed less no matter what the duration, no matter what the distance may be. So let's compare between the close and far male and a close and far female, which is in figure 2. So over here, this is figure 2. And in figure 2, we did a t-test between the males. And we notice that the p-value is 0.04, which is less than 0.05, showing significance in their average means. And we did a t-test between the female, which have a p-value of 0.03328, which shows no significance between the females. So what does this show? It shows 1, male mallards that remain closer has a significant lower average feeding rate than far male mallards. 2, female mallards feeding rates are not significantly different. So keep this in mind as we will come back towards this figure and the stats from it when we go to our discussion. So if you recall our null hypothesis, because p is equal to 0.04, it is less than 0.05, the null hypothesis is rejected and we accept the alternative hypothesis. Thus, closer males will actually have a lesser feeding rate on average. So table 1. So table 1 actually shows the aggression. So in this case, I recorded 15 close male pair formations. 8 of the 15 showed some sort of aggressive behavior towards another male mallard that went close to the female. And that means 33.55% of the time for the close male pair formations. This is juxtaposed with 30.77% of the time for far male pair formations. Moving on to our discussion. So we know that our hypothesis is true, that the closer the male, they have lower feeding rates. However, my discussion is wondering how, like why would they have any? And thus my prediction of mate guarding to be the case. So female mallards spend 35 to 40% more time foraging. So, and meanwhile, male mallards, they actually spend more time showing hostility towards other male mallards. They spend more time in doing other things. So this can explain why, as you know, female mallards just spend more time, males just want to spend more time in just protecting their mate. Furthermore, the closer the pair of male mallards are, the higher testosterone that they have, and higher testosterone can explain why they actually have a more aggressive behavior. Thus, you know, male mallards, they spend more time defending and protecting their mate rather than feeding. While the female mallards feed, the male mallards spend more time looking out for other male mallards. They'll be looking out for any predators. They spend more time observing. They spend more time without their heads down in the water as they can't see. While the female mallards, they can, you know, spend more time in efficiently foraging and eating more food. However, according to figure 2, the mean for the female feeding rates didn't increase or decrease whether the males are far or close. That means when the males are close, it didn't have an effect on the female feeding rate. It doesn't matter about the distance. So in both distances, far and close, female feeding rates were the same. And that means the male didn't really have an effect or didn't affect the female feeding rates. Because when I look at Ashcroft's study again, the study that inspired the study, I noticed that the closer the males, Ashcroft showed that the closer the males are, which will cause higher feeding rates for the female waterfowls. However, this study didn't. It's just that the closer males just had a lower feeding rate. So because of this, it's not conclusive that there was any mate guarding because the females didn't really benefit from the males having a lower feeding rate. There could be another mechanism involved, but it is not mate guarding, and thus my prediction it should be it isn't true. So to go further into some limitation errors, first we have the Canada geese. Of course, you guys know this. If you go to UTSC campus or Waterloo, it's covered in so many Canada geese. And the reason why is because actually upon the beginning of but choosing this area study, there wasn't any Canada geese. But as temperatures lowered, there were a lot of the Canada geese start migrating, and during times of observation, there were some areas where Canada geese were operated around the feeding areas. And thus, I think this will actually affect the feeding rate for both far and close, and perhaps one over the other. So another limitation, maybe even error, is maybe there's no relation to proximity between male and female. Maybe they're just independent of one another. And the fact that maybe the male mallards, you just go to another area where it just have higher densities of food that they can eat. And thus closer proximity, they eat less because there's more mallards eating in that area. So I could have just made maybe a false, basically, correlation between the proximity and the feeding rate. Finally, for future studies, first, marking and tagging the mallards. Mallards, they fly and migrate. So each sample was under the assumption that no mallards are resampled. I did a 2-sample t-test. I think by tagging mallards, again, we will notice when we are resampling the mallards. Furthermore, more research on mallard behavior, especially during autumn, is needed. Especially, I think, because noticing, I need to clarify, I guess, more if the pairs are actually bonded or not. And also I think more research upon that and research on other different behaviors that a mallard have that may not just be because they're bonded. And finally, we are looking at items per minute and basically how many times they dunk their heads into the water. But this isn't indicative of actually them feeding or ingesting or digesting food. So if you actually look at their fecal matter or look into some other way, we can perhaps evaluate the total energy taken by the mallards in another different aspect other than items per minute. So finally, our conclusion. Our conclusion is that the hypothesis that male mallards show significant decrease in feeding rates near the female rates during autumn is supported, but the reasons why remain to be questioned with further research. Because my prediction that male mallards have less feeding rate because of mate guarding is non-conclusive, as the female mallards did not benefit from the male mallard's lower feeding rate. Therefore, there could be another mechanism behind of why the female mallards did not have a higher feeding rates when the male mallards are closer. Thus, this concludes my my presentation. Here are my references. I hope to see you all soon, and I thank you for watching this recording.